the last session we were talking about weight attribute. Weight is an optional attribute. Optional transitive attribute. Weight is an optional transitive attribute. Now, weight and local preference. The difference is weight is within the AS. Weight attribute is within the AS. Local preference is also within the AS. So do you hear me? Weight, yes. Weight is within the AS. Local preference is also within the AS. Then what is the difference? Exactly. Local preference, when you configure on one router, all other routers within the autonomous system will know about the local preference that we configure. The higher the local preference, more preference is given to that neighbor. But here, weight. If you will have more than one path, it may be eBGP or IBGP neighbor, that doesn't matter. The neighbor to which you attach more weight will be the preferred gateway. For example, here neighbor B, to neighbor B, the weightage is 200. So when a packet arrives to this router A with a destination 172.20.00, the packet is going to exit towards router B. The packet will go to router B. Router B will become the gateway. Now, this is an important page. This will solve a lot of confusion. I'll read it quickly for you, don't worry. When you have multiple paths, for a destination network, usually if the path have got same cost, the routing table will have up to 4 equal cost paths. Do you know that? Take RIP protocol. If you have same number of hop count via multiple paths to reach a destination, multiple paths will be seen in the routing table, and load balancing will be done on all the paths. You know that? In OSPF also same. EIGRP also same. ISI is also same. Yes, it will be shared via multiple paths because all the paths have got same cost. Equal cost multiple. But BGP is not designed to perform load balancing. BGP is not designed to perform load balancing. See, if the metric is bandwidth, then paths with same bandwidth to destination will be used for packet forwarding. But BGP is not going to focus on bandwidth. BGP decides a path based on policy. Paths are elected based on policy, not based on any metric. No hop count, no bandwidth, no delay. It's only based on the policy. So if someone asks, will there be a equal cost multipathing support in BGP? Answer is no. It is not designed like that. So even if you have multiple paths, it is going to eliminate and select only one best path among many. How it picks that one best path, based on what it picks the one best path, based on attribute, it does the iteration and pick one path. When the path is elected based on the attribute by following the attribute list, what is attribute list? We are going to see that. It is the list of criteria which is checked in sequence. So when the attributes are checked in sequence, one best path will be elected among many. So question is again, can BGP do equal cost multipathing? No. No. BGP is not designed like that. So the best path after iteration through the attributes list in sequence, the best path is now submitted to the routing table manager. Have you heard about routing table manager? No, in the router, yes. This is the one which is deciding whether to keep the route in the routing table or not. RIB, yeah, RIB is one of the component in the routing table manager, routing information base. So now this routing table manager, what it does is it evaluates, because the routes are given by BGP, it is not going to take it. According to routing table, what is important to decide on the path? Administrative distance. If BGP, in BGP we have IBGP and EBGP, we know that. If IBGP gives the administrative distance is 200, if EBGP gives the administrative distance is 20. Now you see, a route is given by IBGP. The same network information is given by OSPF. Which one the router is going to choose? The OSPF. So that is what's said here. The best path is submitted to the routing table manager process and evaluated against the methods of other routing protocol for reaching the network using the administrative distance. The route from the source, which is lowest administrative distance, is installed into the routing table. Now I want you to go through this entire page. Whenever OSPF, BGP work together, and if both give the same destination network path info, BGP, if it is EBGP, no problem. EBGP is 20 only, will be used. OSPF will be ignored. But if it is IBGP, it is not going to use IBGP given route, rather it will use OSPF given route. Did you understand this? All right. So the best path is submitted into the routing table manager using the administrative distance. Now, there is something which was in the previous chapter. So if you see here, there is something called rib failure. This is what we were just talking about. You see, here is a network. This router is learning it from OSPF as well as IBGP. The network is 172.31.1.0/24. Both are giving, OSPF is giving, and the administrative distance is 110. IBGP is giving, the administrative distance is 200. So in the routing table, if you check, you will not see B, you will see O. Now, if you want to know why BGP's route is not taken, then you type this command and see show IP BGP rib failure. It will show this is valid, but unfortunately, the higher administrative distance. So this BGP's recommendation is ignored by routing table information base. You understand? Now in BGP table also you can find it. You will see R. You see this one R. You know this R? R means rib failure, which means BGP is giving you the best, but according to the rib, this is not best. Why? Rib has received that same network 172.31.1/24 from some other source. Some other source whose administrative distance is lower. Just one more page, you will get a clear picture of attribute. Only then we can do that. This is the attribute list. This is the sequence, order in which the attributes will be checked. Whenever you have multiple paths, what did we learn? Whenever you have multiple paths, it will eliminate. That's what you learned, right? And it will pick only the single path. Now, you got multiple paths. First thing is, zeroth attribute is the next hop valid for both neighbor? Two paths are there now. Multiple paths we are talking about. For a destination, you have multiple paths. Is both the path having next hop reachable? If it is true, only then it will come to first attribute. If one is not valid next hop, then that path will be ignored and the valid next hop path will be taken, and none of this attribute will be useful. Why? The tie break happened here itself. You understand? First thing is, it will check the valid next hop. If both the paths have same next hop, if both the paths for the same destination have got valid reachable next hop, only then it will come to attribute number 1. Now it will compare whether the weight has been set. What is the default weight? What is the default weight? 0. But what if the network is on the router? If the network is on the router, the weight is going to be 32768. Yeah. So now you see here, this one particular network is locally learned, and it is also learned from another neighbor. Automatically, this will be considered as best. You see, do you have the greater than symbol here? No. For this path, greater than symbol is not present. So in the routing table, you will have only this path, not this path. Why? High weightage is preferred, the default weightage is 0. You understood, sir? Now, if there is tie in the weight, for example, if you see here, for this network, I'm learning from two sources. Both are reachable next hop. Both have same 0, 0 weightage. Now it will check the local preference. Both don't have local preference, which means these are EBGP. If it is IBGP, then it will be 100. If it is IBGP, then it is 100. Let's say, let's assume that this is IBGP neighbor. Then you will have 100. Here it is null. Then this will be preferred. But here both are EBGP. So there is no local preference. So it will check the next attribute. Next attribute is it will prefer the one with the next hop 0, 0, 0. Anyway, that is not needed because already weight has made this local one, and the weight will be 32768. Now, what if both don't have next stop 0, 0, 0? In our case, do we have 0, 0, 0? What is? No, I'm asking for this network. Do you have 0, 0, 0 for both? No. So, if there is a tie, then it will prefer the one with the shortest AS path. Attribute number 4. Shortest AS path. In this example, this is also 2 hop. This is also 2 hop. It originates from one place, but it is coming via 2 different paths. 98 and 99, 2 different autonomous systems, but both have 2 hops. Again, there is a tie. In case if it is like this, 1 hop and 2 hop, it would have preferred a 1 hop path. You understand? Only 1 hop. And it ignores the other one. But in our case, in this example, both are tie breaker. Sorry, tie. Both are a tie. Do we have shortest AS path? No. Both are equal. Then what it does, it prefers the path with the origin code I over question mark. What is I? Advertised using network command. You remember we learned. What is question mark? Redistribute. So it will prefer I because I is smaller than question mark. You understood? Lowest origin code. So in our example, all are I. I don't have that table with question mark here. Do you have any question mark? All are I. So next. Yeah, again there is a type. because both are I. If there is one question mark and one with I, which one it would have preferred? I will be preferred. But condition is only if the above attributes are tied. Only if all these are tied, then it will compare with this one. See, this is not going to be effective if the weight is a tiebreaker. You understood clearly? If weight will have a tiebreak, then this will never be used to shortlist the path. Or if one path is shortest than the other one, then it won't come here. Now, this is only if you have multiple exit, because it is multi-exit discriminated. If you have multi-exit like this, which one to go? This one to go or this one to go? It depends on what they advertise. This guy is advertising 150 MED. This guy is advertising 200. Lowest MED is preferred, so it will go via this way. But for this two condition, one, the tie should be there up to 5 attribute, and it should be a multi-homed, means two connections to same autonomous system, as I showed you in the previous page. Did you understand? It should be like this, multi-homed. Sorry, dual homed. This is called dual home. Two connections to same autonomous system. Only in this situation, MED is possible. If you have two separate autonomous system, MED is not possible. Did you understand, sir? Now, if there is tie in all this 6 attribute, when there is tie in all the above 6 attribute, only then it will check the 7th attribute. See, from 7th attribute, you cannot do any configuration. They are automatic. It will prefer the EBGP over IBGP. Next, what if both are IBGP? Then it will prefer the IBGP neighbor who is closest, meaning less metric, the nearest IBGP, the nearest IGP neighbor. Now, what if both are EBGP? If both are IBGP, closest IGP. What if both are EBGP? Then oldest route from EBGP. Now, even though you have two EBGP, one EBGP might have given the network information before the other one. For example, you take internet connection from Etisalat and from Orido. Orido, you took internet connection last month. Etisalat, you took today. So BGP is going to prefer Orido because Orido is old one. It gave me route 1 month before. Okay. Next. What if both give at the same millisecond time, which is not possible, assumed. Mostly this will be the tie break. Assume that both gave at the same time. Orido and Etisalat gave routes at the same time. Now it will compare the router ID of the giver. Whose router ID is lower? Definitely one guy's router ID will be lower than the other. Yes, no. So the lowest neighbor router ID router will be the gateway. What if, very rare case, both have same router ID? It's not possible. Assume some mistake has happened. Same router ID, two neighbor. So there won't be lower, no? In that case, IP address will be definitely lower. The one with the neighbor whose IP address is lower will be the preferred path. Is that clear, sir? Is that clear? One of the neighbor will be having small IP address than the other one. Whether it is public address or private address, definitely. Next up, only neighbor address. Next up, only neighbor address. Both are same only. One next up address will be smaller than the other one, no? Not okay. You see here. This next stop address is lower than this one, no? So, in the beginning, it was only seeing reachable next stop. Here it was seeing only reachable next stop. It is not seeing whether lower or higher. Lower or higher is seen only here. Only if the only when there is tie in all this, it will come here. Autonomous system address. Yeah, you can see here. You can see here it is from 89, sorry, 98, 99. 98 is 1.3, 99 is 11.4. So which one is lower? This one is lower. That is why this is best. Just the star is valid only. For a route to be considered in the routing table, it needs to be both valid and best. Star and greater than signal. Now, this is very important to know in sequence.